So, our solar system's got a visitor, an interstellar comet streaking in from deep space called 3I/Atlas. But this is way more than just a cosmic flyby. This thing is giving astronomers a massive headache because, well, it seems to be breaking the laws of physics. So what's the big deal? It's actually pretty simple. 3I/Atlas is moving in a way that just doesn't line up with everything we know about how objects should orbit in space. It's not playing by the rules, and that begs the question, what is really going on out there? Basically, what it boils down to is a massive contradiction. It's a direct clash between what our physics models predict should happen and what our telescopes are actually showing us. And here's that contradiction in a nutshell. As 3I/Atlas flies away from the sun, the solar wind, this constant stream of particles flowing outwards, should be hitting it from behind. It should act like a tailwind, giving it a little push and making it speed up. But yeah, that's not what's happening. Instead, it's like someone slammed on a powerful invisible brake. This comet came screaming into our system at a blistering 26 kilometers per second. That's pretty standard for an object from interstellar space. But as astronomers kept watching, they noticed it was slowing down. Now, you might think, a slight slowdown, so what? But in astrophysics, a slight change like this is huge. It's way too big to just be a mistake in the measurements. Okay, so before we all jump to crazy conclusions, like aliens, scientists have to do their due diligence. They have to go through the checklist and rule out all the normal, boring explanations. It's time to round up the usual suspects in this cosmic mystery. First up, the most obvious culprit, cometary drag. You know how when a comet gets close to the sun, its ice heats up and shoots out gas, creating that beautiful tail? Well, that process can act like little rocket thrusters, changing its speed. But when they looked at 3I/Atlas, they saw almost nothing. Barely any gas, no significant tail, so there's just no way it's producing enough thrust to cause this kind of braking. Suspect number 1 is off the list. All right, suspect number 2, gravity. Maybe the combined pull from the sun and all the planets is messing with it. So the experts crunched all the numbers, they modeled every little gravitational nudge from Jupiter, solar tides, the whole shebang, and the result? Nope, not even close. Those forces are definitely there, but they can only explain a tiny fraction of the slowdown. So gravity's out too. And this, right here, is where things get really interesting. Because once you've thrown out all the simple textbook answers, you're left with something profound. It means some other force, a powerful force that we haven't accounted for, has to be pulling the strings. So, what could this mystery force be? Well, the leading theory is pretty wild. It totally reframes what we think this comet is. It's called the magneto-metallic attraction hypothesis. Let's just call it the MMA hypothesis for short. The core idea here is that we've been looking at the wrong force entirely. Forget gravity. This is all about magnetism. The theory suggests there's a super strong magnetic pull between the comet and the sun, and that this force is powerful enough to act like a brake on our interstellar visitor. See, according to this hypothesis, this thing is no ordinary comet, no dusty snowball. It's an absolute monster, an object weighing a staggering 33 billion tons, packed with an unusually high amount of metals, like nickel. And this crazy composition means it's basically become a giant traveling magnet. So picture this as a giant cosmic tug-of-war. On one side, you've got the solar wind giving it a gentle push forward. On the other side, you've got the sun's gravity pulling it back. But the MMA hypothesis says there's this huge, invisible player on the brakes team, a powerful magnetic attraction fighting against the comet's forward motion. And the scientist who came up with this, Alexander Campaign, put it perfectly. He says, this magnetic attraction is that mystery force we've been looking for, and it's more than strong enough to completely overpower that push from the solar wind and explain the slowdown we're seeing. But hold on, the giant magnet theory isn't the only game in town. When you've got a mystery this big, it's gonna attract some, let's say, more out there ideas, even from some very well-respected scientists who think we need to keep our minds open. Take Harvard's Avi Loeb. He's famous for thinking outside the box, and he's suggesting we shouldn't dismiss the possibility that this slowdown isn't natural at all. He basically says that this kind of controlled deceleration could point to some kind of mechanical or structural property of the object itself. It's a big leap for sure, but he argues the data is so strange we have to investigate every possibility. And the reason this idea has some legs is because This isn't the first time an interstellar visitor has acted weird. Remember Oumuamua back in 2017? It also defied our models, but it did the complete opposite. It sped up as it left the sun, without any tail. And now we've got an object that's slowing down for no clear reason. You see the pattern here, right? Two interstellar objects, two opposite unexplained behaviors. So after all that, where do we stand? Well, the case of Comet 3I/Atlas is wide open. We've thrown out all the easy answers, and what's left is a handful of truly extraordinary possibilities. We've got our lineup of the three main suspects. First, you've got the leading scientific theory. It's a giant metal magnet. Second, there's the speculative theory. Its unique structure, maybe even an artificial one, is causing the slowdown. And third, you have the skeptical view. Maybe it's all just a mistake, an error in our data from trying to track a very faint, distant object. And that's the incredible question we're left with, isn't it? Is this comet revealing a brand new force of nature we never knew existed? Could it be a piece of alien technology, as some dare to wonder? Or is it all just a simple miscalculation? No matter what the answer turns out to be, one thing is for sure. This strange visitor is a powerful reminder that the universe is still full of surprises.